Okay. See? Put it on there, and that's 3.25. I'll say this unit weighs 41.87 kilograms. Okay, so let's put that on the board. That is probably this one that way, and this one go that way. Here. So there you can see, guys, the screen changed to that one. Okay, so these are the blades that I must grind. Welcome back to the channel, guys, and to another video. In this video I'll be completing the balancing of the rotating element. I'll be carrying on with the calibration putty when this video starts now. So I hope you guys enjoy the procedures. And run it again. Okay, so once she's up to speed and I stopped it, she says 4.38 at 303, 4.90 at 253. So now I'm going to put on the calibration putty, and that I put on at 0. So I'll come here, she's at 0 there, put the putty on, make sure it's nice and firm. Otherwise it will just fling off when you work the machine. So now start it again. Should go up to 1,000 again. Okay, so once it's full green, I'll press H here and I'll stop it. And then the moment she stops, I'll take the putty off this side and I'll put it this side. Let me just assist with the stopping here. Okay, so I'll take this putty off here. I'll turn it to 0 and I'll put it here on this one here, because that's at 0 there. So I'll put it here, I'll make it nice and firm in the center of this unit. Okay, I'll start it again, and away she goes. So once she reaches there, I'll press H again, I'll stop, and I'll press enter. See, then that will pop up there. So there it will say input value of mass on left plane. That is when it was on that side, right? So we can recall that was 3.25 grams. So I'll just punch in here 3.25 and I'll press OK. Then it asks input value of degrees. Remember, I put it on 0, so I'll just punch in 0 again. I'll press OK. Then it will say right plane mass, and I use the same putty, and that was 3.25 grams. I press OK, and there they ask again now the degrees that I put it on, which was 0 degrees. I press OK. Now I'll remove this putty from here. Now I'll see what the actual weight is that must come off. So now I'll start the machine again. So So the calibration putty put the unbalance in the system. The computer first read the unbalance of this unit, and it registered that. So now I put the putty on, so now that throws that unbalance out, so now the computer will tell exactly what must come off. So there you can see 34 grams must come off at 45 degrees, 40 grams must come off at 286. So I'll just print this quickly. Let me just start it again. I started it now again just in order to print it. So she'll run up again to speed. Okay, there we go. Once it's full, I'll just stop it and I'll print it. Alright, so there we have it, guys. 520 impeller. There's the mass. It's a bronze vacuum element. That's all the specifications, the radiuses and stuff. So you can see it's a double plane. So this thing says a static permissible mass is 15 grams. That is quite a lot for this thing. But you know, like I said, I like to bring that down to the bare minimum. And that's the unbalanced masses, obviously unqualified. So yeah, I'm going to start doing all the grinding and we'll see what happens. Okay, so as the computer says 34 at 45, 40 at 286, I marked it out. So that this would be at the 45 degree here. So that I'll be taking off there. I'll be taking off there because you can actually see how fat this is here. But this wouldn't be the whole 34 grams here. It's probably, this one probably influences as well. And on this side was 286, and I marked that out there. 286 falls here, so I'll just grind a bit down there, and probably this mass here will influence this as well, but I'll just grind in down there and I'll see what happens. So I'm not going to show you all this grinding, guys, because the clip that I showed you when I grinded this slot here prior to doing all the balancing, that's basically what's going to happen now. So that's going to be a tedious job because I'll probably take this thing off this machine easily 20-30 times, and I'm not going to record me grinding, but the same thing that I've done here is what I will do to this whole thing, and I'll just show you once it's all balanced up. Because like I said, once I get to degrees, I mark it out like that. You know, I mark it out like that. And like that. Also, I'll grind in there. And then, yeah, this just... So when I'll see you again, she'll be balanced. Okay, guys, so this was one long day. If you can see, I basically had to grind every vein on here. On certain eye spots and stuff. This was one long day. There was no way I could have recorded me grinding here. But you all know what that grinding looked like. So I'll run it now, then you can see what the results was. So there you can see 2.43, 314 degrees, 3.80, 234 degrees, and they're all there. Computer saying it's good. So I say job done. So what I'll do now, I'll just print it and I'll show you the comparison. Okay, Okay, there we go, qualified. That's the result. I'll just compare it with the other one. Okay, so there we go, guys. Same job, unqualified. You can see where the masses are and the degrees, the revolutions, the static mass degrees here, and this is it, qualified. All sorted out. Okay, so that came to the end of the conclusion of that balancing of that unit. So that's all sorted out there. It took some time balancing that. You know, these units normally take a good few hours to balance, because each vein you virtually have to grind both sides, you know, so it's quite a tedious, quite a long job, you know. But in the meanwhile, I received another unit, which was cast iron, a bigger unit to the phosphor bronze one, which I've been showing you now. So I'll just show you just a few little clips of the procedures that I went through on the cast iron one, which is it's exactly the same as the phosphor bronze one, except this unit was much heavier and the steel was much harder. Enjoy this segment, guys. As you can see here, also took some significant grinding on this to get this thing into balance. This cast iron was very hard, so I'm going to start the machine now and show you what the result was. One was quite out. I had to take off 579 grams on the right side, which is the bigger impeller side, and on the left side I had to take off almost 300 grams. But she's within the circle, so that's good enough. I mean, I could carry on. I could carry on and get it down closer. But like I said, if the machine qualifies it because it was in the tolerance for the weight and the size of this job, then I'm all good with that. So another job well done. Okay, so that was that, guys. That was the cast iron one, all balanced up. That took quite a bit of work. Like I said, it took almost 3 days, 2.5 days to balance, purely because of the hardness of the steel. Okay, so I balanced that that unit at 500, whereas the phosphor bronze one I done at 1000. Generally, if the diameter of a single plane impeller exceeds 400, or the weight of a unit exceeds 50 kilograms, I generally bring it the testing, the balancing speed down for safety reasons, which doesn't really affect the end result, because the operational speed is put into the computer in the beginning with all the information, all the data that I capture. So then the algorithms work out the balancing at 1400 or whatever the actual operating speed is, irrelevant of the balancing speed. Don't forget to hit the notification bell. Don't forget to tell your friends about it. Don't forget to subscribe, like, comment, share, all the good stuff. And until we meet on the next one, have a good one, guys. Thanks for watching.
Can anybody out there hear me? Hear me?